Hello, welcome to AQA demola, and today we're going to tackle something really difficult, water crystallization. I think first of all we'll begin with talking about the practical, and then we're going to get into how do we tackle these calculations. So no time to waste, let's get into it now. Okay, this topic is more calculation based, but I think it's really important to understand the experiment as well, because that just helps you to have more context and also in terms of answering questions. So we're going to quickly run through it. Here's your kind of apparatus. So you got your, sometimes they'll call it an evaporating basin. I prefer to call it a crucible. It's kind of this thing made of clay, and then you put your salt into it, yeah? And then you've got your tripod, your Bunsen burner, as I've drawn there, to the best of my abilities. Cool, but we're gonna go into the experiment. So, really important, you weigh the empty crucible with the lid, then you put in the salts. So this will be the one that you got in your school. Use a spatula, put it into the crucible. Sometimes it will be, so it doesn't really matter. I'd probably do like 2 teaspoons. Then you weigh the crucible with the lid and the hydrated salt, yeah? Then, now you're going to put it on the pipe clay triangle, over a tripod. You use the Bunsen burner, you put it on the hot flame, yeah, the roaring flame, and you let that heat for a couple minutes. Cool. Afterwards, crucible cools down. You use your tongs to take it off, let it cool down, yeah? And then you're going to weigh the crucible with the lid and the salt. Cool. You have to keep repeating that process until you get consecutive readings where the mass is constant. Really important. In fact, we're going to highlight it. Really important that you know that you're looking for constant mass. Big marks in the exam, constant mass. And that means that all the water's been moved and you have your anhydrous salt. So you end up having a table kind of like this, where you've got the mass of the empty crucible, the lid, the mass of the crucible lid and the hydrated salt, mass of the crucible lid and the anhydrous salt. And you're going to use the values from that to do your calculations. So then I just think it's important to just know definitions. So your hydrated salt with water molecules in its crystal structure, and they tend to be written as something like, for example, if we said sodium hydroxide, NaOH dot xH₂O. That's how they tend to be expressed. Whereas the anhydrous salt is the salt without water molecules in its crystal structure. So that will just be NaOH. You get. And I just think it's also important. I just think it's also important to just know an example. So with copper sulfate, hydrated copper sulfate, that tends to be blue, whilst anhydrous copper sulfate tends to be white. I think that's just a good one to just put in the back of your memory, have it in your arsenal in case that comes up in the exam. So now we've gone through the experiment, let's get into calculations. Okay, so we've got a worked example here, and I'm going to do my best not to be too long-winded with this, but I'd prefer that we get this done in a lot of detail so that whenever a question like this comes, you know how to approach it. So let's read. A student heats a sample of hydrated magnesium sulfate to remove its water crystallization. We've got the mass of the empty crucible, 28.42 grams. The mass of the crucible with the hydrated salt, 30.68 grams. And the mass of the crucible and the anhydrous salt, which is going to be 30.00 grams. Use this information to calculate the formula of the hydrated magnesium sulfate, giving your answer in the form MgSO₄ dot xH₂O, where x is a whole number. Now, you can see in blue, I've got different steps of the process. And I'm going to explain what we're doing and why we're doing it. Cool. First of all, to do a calculation like this, we need the mass of the hydrated salt. Right? Then we're going to need the mass of the anhydrous salt, and we're going to need the mass of water loss. So, first of all, we're going to define this, the mass of the empty crucible, as mass 1. We're going to define with the hydrated salt as mass 2. And we're going to do the anhydrous salt as mass 3. Really, really important that you define these straight away. Now, to get the mass of the hydrated salt, let's think logically. We're going to need to do mass 2 take mass 1. So we're going to do mass 2 take mass 1. Yeah? So let's put in the actual values. We're going to add the 30.68 minus the 28.42. Excuse my handwriting. And what we're going to get is 2.26 grams. Yeah? Calculators out, remember. Cool. Anhydrous salt. Similarly, this time, it's going to be mass 3 take mass 1. I hope that makes sense because the only difference between mass 3 and mass 1 is that the anhydrous salt is there. So again, let's plug in the values. We're going to do 30.00 minus 28.42 and we're going to get 1.58 grams. Okay. Finally, the last thing we need to do to set ourselves up is we need to figure out what the mass of water loss is. Yeah. What's the difference between the hydrated salt and the anhydrous salt? It's water.
So what we actually need to do here is we need to take the mass of the hydrated salt from the mass of the anhydrous salt. So we're going to do 2.26 minus 1.58, giving you 0.68 grams of water loss. Okay. Let's move on to step 2. We need to find the moles of anhydrous magnesium sulfate and the moles of water. So how are we going to do that? Let's zoom into our handy periodic table. Yeah, magnesium sulfate. Magnesium, sulfur, let's find it here. Oxygen's there. And I think that's all we need to be aware of. I mean, also with water, hydrogen and oxygen. And oxygen's already highlighted. So, let's find out what the MR, the molar mass of magnesium sulfate is. MgSO₄ is going to be equal to 24.3, as we figured out from magnesium, plus the 32.1 from sulfur, plus 16 lots, or 4 lots of 16 for oxygen, right? Hope that makes sense. That gives you a molar mass of 120.4 grams per mole. So let's remember that. Now, to get the moles of anhydrous magnesium sulfate, again, link it back. Mass divided by molar mass equals number of moles. So, for moles of anhydrous MgSO₄, the calculation we're going to do is the anhydrous mass was 1.58. 1.58 grams divided by that 120.4 gram per mole. And we're going to get our answer as 0.0131 moles. I've rounded. I would recommend you not to round. Just use the number in your calculator. Moles of water, we can also find out, right? We had the mass of water. Look up 0.68. So 0.68 grams divided by the ml of water. Well, 2 hydrogen, 2, plus oxygen, 16, which means total is 18 grams per mole. And that gets us a value of 0.0378 moles. Again, rounded to 3 significant figures. And the last thing we need to do is find the molar ratio of water to magnesium sulfate. We need to find out how many molecules of water there are for every molecule of magnesium sulfate. So we just do division. 0.0378 divided by 0.0131 is equal to 2.88 to 3 significant figures. So we're going to round to 3. Yeah? Nearest whole number, remember, that's what the question asked. So if x equals 3, we can write out this formula as MgSO₄ dot 3H₂O. I hope that explanation makes sense as to how we've managed to get this answer. If you need to rewind, go back through it. We're going to get into examples. Okay, so apologies. It was a hassle to get all of this on the page. But I'll just zoom into some places. So this is just question stem, right? Hydrated strontium chloride, and that's the formula. They've explained the method and they're giving you these values, yeah? You're going to use those values to work out the part I, yeah, the value of x. And then there's part II about why they've taken 4 readings. And then the last question is going to be part I, about 2 modifications. So we'll zoom out. I hope you can see that quite clearly. The most relevant thing here is going to be the table and the questions, right? So have a read of that and pause the video. Okay, here are your answers. So 5.8 gets you the answer straight away. There's something I love about chemistry. If you get the right answer, they give it to you straight away. But look here. We did the same thing that we did, yeah? You found the moles of the strontium chloride. You found the moles of water. And then you need to find the ratio, yeah? Once you've got the ratio, that tells you all you need to know. Cool. This question did say ability to see significant figures. So that's why you have a bit of a difference there. Now, what else have we got? Oh, by the way, I think they've done it wrong there. So the ratio is actually water to strontium chloride. That's just a problem with the mark scheme. You can see with the actual calculation they did that they did water to strontium chloride. So just be aware of that. Now, part I. Remember we said the reason why we do multiple readings, and I said this in the method, was because you need to keep going until you get a constant mass. So you see here, they actually do not accept constant mass because although that's what you're doing, you're heating to constant mass. The reason why we do it is because all the water is removed. So that seems to have caught a lot of people out based on what they've said in the examiner's comments anyway. But just be aware about that as well. The reason why we're doing 2 constant mass, so if you're talking about method, achieving constant mass is going to be a mark if you're talking about the method. If we're talking about the rationale, we need to say it's about removing the water. So that's a really important distinction to make as well. Now, about improving your accuracy, guys, I hate these questions, but the good thing about these questions is the answers are almost always the same. So it's going to be about using a balance that has more decimal places. It's going to be about using a larger mass. Literally, I would say just kind of stick to those two most of the time when you get questions like this, and you probably will get marks. So yeah. Okay, so now we're rounding it up with the A-star tips. Now, guys, use that periodic table. You have it for a reason. In chemistry, most people do tend to finish on time or even early. So make sure that you're using the periodic table in your data sheet to get those molar mass values, unless they've given it in the question. Yeah. Also, look at what the question wants. So like, for example, the example that I did wanted it as a whole number. The next question wanted it to 2 significant figures. Guys, just make sure you answer with what the question wants, because that's such a silly mark to give up in the exam. Yeah. Also, the method. We didn't entirely go into it. The practical. Again, we didn't entirely go into it because this video wasn't about the practical. But you need to make sure you know that method, you know the different equipment you're using, and the safety concerns. So like safety goals, making sure things are on the center of the table. Also, you're working with an open flame can be dangerous. So just make sure that you're aware of the different safety precautions, because a lot of the times in your exam, you will at least have one practical question, which tends to be about 6 marks. So just be aware of that. And also follow the steps of the working and write. I've put it in capitals, guys. Please just write out your workings out. I know that they give you all the marks if you get the right answer, but that is if you get the right answer. If you make a mistake and you didn't put any workings out, you don't get any marks. So it's just safer to always write the workings out. Yeah. What do you not do? Guys, I'm a massive advocate for this. Do not round early. You will lose marks if you round early because your final answer won't be correct. Yeah. Don't be vague with explanations, especially when you're doing practicals. You are going to want to say things like constant mass, which is my next one. You are going to want to say things like that when you're describing your practical. You're going to want to be very specific about the equipment that they're using so the examiner can't say, oh, maybe they don't know what they're talking about, yeah? So just be aware of things like that. Okay, that's a wrap for this video. Thank you so much for watching. I hope it's been really helpful to understand more about this topic. Any questions, leave it in the comments below. Please drop a like, subscribe to the channel. Also trying to push the TikTok and the Instagram, both at A*demola. Link will be in the video description, and I'll see you in the next one. Bye for now.